now continuing on the remote sensing track, Vince Michelanis is going to share some information about how we're using remote sensing for utility vegetation management. Go ahead, Vince.
All right, thanks, Justin. Good morning or afternoon, everybody. We want to talk a little bit about some work that DRG has been doing with Florida Power and Light. The objective of this is the client was really lacking a full inventory of the vegetation around their utility lines, and so they wanted to assess the amount of vegetation that they had and what the accessibility of that vegetation is in terms of lift versus climb. Some uses of this and what we delivered was creating a GIS layer that will allow them to prescribe tree work, forecast budgets, and determine resources and staffing levels. And all of this is based off of aerial imagery and not putting a full workforce on the ground. To date, in really a short amount of time, nearly a third of FPL's 35,000 line miles have been analyzed by DRG using this methodology. Next slide, Justin. So what we did was we extracted vegetation polygon layers. We used remote sensing and machine learning software to automate the canopy extraction from NAPE aerial imagery. That NAPE imagery is readily available on the internet. Its regular flights are conducted. It's government imagery, so it's easy to access for us. We also wanted to do a QA/QC process to make sure that what we were finding in the imagery reflected conditions on the ground. So we processed the imagery along with taking in urban pavement base layers, essentially the street lines that you would see on a map with from the city, and we put specified buffers along there. So if we assumed that a bucket truck can reach 20 feet on either side of that street, that's what we were going to assume is accessible by a lift truck. Anything else would be considered climb or backyard trees. So we used tools to convert the vegetation polygons into a linear trim layer, and we assigned the accessibility based on the proximity to those street center lines and the buffers for each one of the line segments. The overhead primary attribute data was joined to each linear segment, and we ground truthed to produce a final density result. And on the next slide, you can see an example of the map that we were able to produce. The red areas are considered accessible, green areas are considered accessible for lift, and the blue areas are considered areas that do not have any vegetation, so the utility doesn't need to include those in their workload estimates. We're also able to provide a data table which shows the same information and summarizes it by each circuit. And what's a little hard to see here on this slide, they were able to get all of the information that's displayed on the map into a data table that they can provide to their contractors for bidding purposes. And next slide. So what we were able to complete the spring of 2016, we completed the proof of concept. We did about 320 linear miles of the system, and we were able to validate the measurements to meet or exceed FPL's expectations for target variance. So we sent some field crews in, verified that what we were seeing in the aerial photos and the analysis that we were doing matched the conditions on the ground. Summer of 2016, we completed another 9,300 miles, and that completed the Western Region Distribution Network for the client, one of their large areas. And we also were able to compare the density between 2015 and 2013 NAPE imagery to see what the amount of the change that was going on in the vegetation, where they were doing removals or where vegetation was being added to the system. In spring of 2017, we completed another 1,800 miles, and that completed the southern region for the client. And next slide. And so what we learned, we learned that we really are able to differentiate vegetation from other features and shadows that appear in the imagery, and that matches the conditions on the ground. We were able to tweak and train the software that we were using to provide more accurate vegetation extraction. As we use machine learning, the computers start to learn more and more what type of features that are on the photos match what vegetation is versus hardscape and shrubs and grass. We were also able to increase the automated processing, which further increases our efficiency and provides better consistency and quality of the data returned. The next steps is we will use the newly acquired 2017 NAEP imagery once everything gets flown and the government is able to post it to the systems where we can download it. And we'll continue to leverage access to high-resolution imagery to aid in the QA/QC process. There's additional imagery that we can use. There's other data such as LiDAR that we can use that we can combine with this aerial imagery to increase the efficiency of the extractions and the quality of the data that we provide.